Example 1. In how many ways can you arrange 2 letters from the word fun? We know that's simply 3 permute 2 because there are 3 total letters and we want to arrange 2 of the 3, which is of course 6. So here I've listed all of the actual 6 arrangements of 2 of the letters from fun. So we've got FU, UF, and FN, NF, UN, and NU. But what if the order of the letters that we're picking don't actually matter? So really, now we're only asking how many different ways can you pick 2 letters from the 3 letters in fun? So essentially, these 2 would be the same pick because FU and UF, it doesn't matter the arrangement, I'm just picking them. So I have 1, 2, 3 different ways I can pull 2 letters from the 3 letters fun. And that is actually called choosing, okay? So that would be 3 choose 2, and that's equal to 3. You may also see this written as 3 choose 2 vertically like this with the brackets. So make sure that you don't have the divisor line there because that is 3 divided by 2, and that's of course 1.5 and not choosing. So no divisor, just stack them. Now let's take a look at the formula and why this all works. So let's start back here with our permutations formula. 3 choose 2 did start, and it's very similar to the permutations formula, so 3 permute 2, except we only found that it was half of our original permutation. And that's, of course, because for every 2 letters that we picked up here, there were 2 combinations or arrangements of how we could organize those letters, right? Which is really like saying 2 factorial, okay? So more generally, for any number of items, choosing our number of items from them, so we're picking them where the order doesn't matter, it is equal to the permutation of N and R divided by the number of items that you're actually choosing, factorial, so R factorial. So same like that, just over here. Now, we do know that the permutation formula is, of course, N factorial over N minus R factorial, and then that would be divided by R factorial, but we will simplify. So N choose R is equal to N factorial over R factorial times N minus R factorial. So that is your combinations formula. However, you should be able to do this on a good scientific calculator, so make sure, just like with the permutations, that you do know how to plug in any combinations questions into your calculator. In how many ways can the following cards be chosen from a deck of playing cards? Usually when we're working with playing card questions, these questions will often be choosing questions or combinations questions, not permutations questions, because when you have a set of cards in your hand, if you're playing a game, the order in which you receive these cards doesn't actually matter. You can shuffle the cards in your hand as long as they're in your hand. So these are combinations questions. So any 4 cards would just mean that we are starting with 52 and we are choosing 4. And if you type that into your calculator, you're going to get 270,725. So 270,725. And if you wanted to do this by hand, it would look a little something like this. So you've got 52, choose 4, which would equal to 52 factorial over 4 factorial times 52 minus 4 factorial, 52 factorial. And the 52 minus 4 simplifies to 48 factorial. And then we can simplify the numerator and the denominator. So I've eliminated the 48 factorial. And then, of course, you could break up, if you really wanted to, the 4 factorial into its factors, and then simplify further. And you will find that your answer is the exact same. How many ways can I pick 4 diamonds? So this is a little bit different because I'm now not picking from the 52 cards. I can only pick diamonds. Since diamonds represent a quarter of the deck because it's one of the 4 suits, that represents 13 cards because 52 divided by 4 is 13. So there are 13 diamonds I can choose from, and I want to choose 4 of them. So 13 choose 4 is 715. The next question asks for 2 kings and, sorry about that, I wanted to say 3 queens. So whenever you have 2 situations happening at the same time, so 2 cases that are happening within the same hand, so in the same hand I want to have both 2 kings and 3 queens, I want to make sure that I'm multiplying both of these. So there are 4 total kings in the deck. So from the 4, I'm choosing 2 of them, and then I'm going to multiply that number by 4 choose 3 for the queens, because of course for the kings, 4 kings choosing 2, queens, 4 queens choosing 3 of them. 4 choose 2 is 6, 4 choose 3 is 4, and 6 times 4 is 24. So there are 24 different hands of 5 cards that incorporate 2 kings and 3 queens. So in general, anytime that we're talking about a combinations question, the operation that we're doing is choosing. So we've already learned about permutations questions, and we permute. In combinations questions, we choose. And we use choosing or combinations when we have a question where the order doesn't matter. If the order does matter, that's a permutations question. So the largest challenge is determining whether the question is asking you to permute or to choose.